So because our results were a little hot, we're going to go ahead and add a fan to this model. The first thing that we're going to do for it is just create a block on top to represent the dimensions of the fan. There are other ways to do this. You don't actually have to do this step. You could just define it within the fan boundary condition, but I find that this is a nice way to do it off. So if we define from the center of it and the size of it, we can first pick the center using just an element center here. We want right in the middle of the model, and then say about here, and then we want it to be 120 millimeters or 0.12 meters in both X and Z. Dimensions. And after doing that, for Y, we'll just want to have this be, say, 3 millimeters thick. And we can make that out of a plastic component, which we don't actually have one, so we'll just add in plastic material, and we can see the fan here. I actually like it to be, from looking at that, maybe a little thicker. So if we come in and we go to this cuboid, which is the one we just made, and can actually increase this now to 5 millimeters, and then maybe bring this to here as well. So for that, we would just want to modify the solid that we have selected here, and we're going to want to translate it. And coming in here, if we just go on to point key plane and select from here to here, and then go to length and select from here to here, then we'll install that in here, and we hit apply, and that'll move our fan so it's now sitting right on top of the heatsink itself. Okay, so we have our fan block there, and it's made out of plastic, so let's just quickly come in here and set our plastic material in our model, and we can just use 0.3 for the conductivity. And then BC fan. So we now want to associate it to that block, so come up here to select the block, and we'll just click on that. There we go. Fan is the name of the solid, then .0 meaning the 0 block. So if there's only one block, that'll be .0 for the heatsink. There are many blocks, so if I click on this, you can see it's heatsink .10. And with any of these, you could just type in, if you know what it is, type in the fan or click on it. If you want multiple, then you can just put spaces in between them. And now we have a fan curve. So for pressure 0, we'll pressure drop of 0.0494, and then for 0 flow rate, say a pressure drop of 50 Pascal. And then the flow direction is going to be in the Y minus direction, because we just want to blow it down this way. Okay, and if we want this to be circular, so we'll actually do circular here, sorry, and 120, remembering that we're in meters, and for this, since we just want it to be right in the center, it'll be 0.06. Oh, sorry, from block center. This is actually going to be 0, 0, because we do want it to be in the center of the block. Hit apply. We can see this now. And I've entered in the diameter instead of the radius. So we go to modify, and instead of being 0.02, it should be 0.06, of course. Okay, so there we have our fan. And that should be all we need. The only thing that I'm going to change here, I'm actually going to take this solid plane and actually kind of spread it out a little more, because we don't really have the ability for air to pool up here. There's a base coming all across here, and then also, since we have forced air now, I'm going to extend the plane a little bit more at the same time. So if we go into modify solids, and we can just come in here and select this solid air. I want to modify in the X direction. Okay. So now looking at our key planes here, we have these extra key planes. We could go through and delete those, but I'll just leave that for now. And I'm actually going to move this key plane down just a touch here. Might not really be important, but can't hurt. So for that, modify, and we can see where our Y is, and that's down here. So if I just want to make that a little lower, I can here. Look at the mesh that we have, make sure that we're not going crazy on our elements. Under 700,000, that'll still run fine, and we should be able to rerun this now. So I'm going to save this model and run. I'll call this one run to fan. When you do click run, it'll store a copy of the model in that folder in case you ever need to go back and reference that. So if you're making changes, you don't actually have a model that matches that run. If you go into that folder, there will be a copy of the model as it was there. Okay, so once again, I'll pause this as it's running. Okay, so this actually converges very quickly in 10 iterations, so let's have a look now at the results. And we can see this made a large difference in our results. Now a temperature of only 106 degrees, well within our range. And we can look again at the results going through and see the plume coming up from the center through the fan. Okay, so that'll end our demonstration. If you wanted more results, you can always use our external viewer using pair view. You could do stream traces, other looks like that. But for now, we'll stop here. Thank you.